Hello everyone, on today's video we will review some common integral examples that you'll see in reactor design. We'll start with a simple example, integration of a constant, 3dx. The 3, since it's a constant, it can leave the integral, so integral of dx, which is 3x. So basically when you integrate a constant, it's the constant times x. So if it's integral of 4 dx, that will equal 4x. Okay. Another example is integral of 1 over x squared. That can be rearranged to be integral of x minus 2. We basically brought this up to the numerator, which will come up with a negative value. Okay, so this is another way of rewriting this here, x over 1 over x squared, sorry. So the integral of x to the power of negative 2 can be solved using this law here, which is integral of x to the power of n equals x to the power of n plus 1 over n plus 1. So let's apply this rule on this example here. It will be integral of x to the power of negative 2 dx. That will equal to x to the power of negative 2 plus 1 over negative 2 plus 1, which will give you x to the power of negative 1 divided by negative 1. Okay, now let's do some examples that are related to reactor design. So we'll say integral of square root of Ca dCa. We'll rearrange that to write it in a different form. The square root is basically to the power of a half. So Ca is to the power of a half dCa. We can use this rule again to solve it, which will give us an answer of Ca to the power of a half plus 1 over a half plus 1, which will equal to Ca 3 over 2, yeah, over 3 over 2. Okay, let's look at another example. Integral of x to the power of 4 over x to the power of 5 dx. First, we need to simplify this term more. So this will cancel. Will be a 1 here. Here will be an x. So basically, you know what? We'll leave this integral for later. I'll show you why. Which is 1 over x dx. Okay, we'll leave that for later. Let's do a simple example of integral of x squared dx. We'll solve it using the same rule, which is this, which will equal to x cubed over 3. Let's look at this now. Okay, no, actually it's too early for it. Let's do a example that's similar to it. Integral of 1 over x cubed. Okay, rearrange that. Integral of x to the power of negative 3 dx, which will equal to x to the power of negative 3 plus 1 over negative 3 plus 1, which will give you an answer of x to the power of negative 2 over negative 2. Now let's look at this here. Okay, integral of 1 over x dx. If we solve it using the same rule, we will end up with integral of, no, we will end up with an answer of x to the power of negative 1, because this here is to the power of 1, plus 1 over negative 1 plus 1, which will give you x to the power of 0 divided by 1 by 0, which does not exist. So this here is a special case and is solved using a different rule, which is integration of 1 over x dx equals ln x. Okay, so let's do some examples for this rule here. Example, integral of 1 over, we'll do it in terms of reactor design, 1 over CA dCA. That will equal to, let's put the limits with the limits of CA naught, which is the initial concentration, to CA, which is the final concentration. That will equal ln CA with limits from CA naught to CA, which will equal ln CA minus ln CA naught, which will give you ln CA over CA naught. Okay, another example we can look at is this here, a partial fraction integral, which is integral of 1 over, before I go there, before I go here, this rule here could also be used in different cases. For example, integral of 1 over x minus 1. You can look at this term as an x, use it as an x, and solve it the same way, which will give you an answer of ln x minus 1. Okay, so likewise, these functions here can be solved the same way as an integral of 1 over x. We'll look at a reactor design example, integral of 1 over CA minus 4, which will equal to ln CA minus 4. Okay, now we can move on to a complex integral example, which is 1 over 1 minus x times 1 minus 2x. This can be solved using a partial fraction. So this function here needs to be divided into two terms that can be integrated, which looks something like this: a over 1 minus x plus b over 1 minus 2x. So we're looking to divide this function in the left side to a function, a partial fraction, like in the right side, and then we can solve each one separately. We can find the integral for each one separately. So in order to do that, we first need to find the unknowns A and B. To do that, we need to make this function here look like the function on the original function on the left side. So to start, we need to find the common denominator to look the same as the original function to the left. We'll do that using cross multiplication. Okay, which is common denominator will be 1 minus x times 1 minus 2x. Top side will be a times 1 minus 2x plus b 1 minus x. Okay, we'll times the variables inside the brackets for the next step, which will give us, this here is the left side, give us a numerator of a minus 2xa plus b minus xb over the denominator, which have not changed. Okay, now we'll factor by grouping. We'll group these together and these together. Why? Because there's a common factor of an x. So the numerator will look something like this: a plus b, which is this and that, minus x, the common factor between those two terms, 2a plus b. The denominator is still the same. Okay, now this numerator needs to equal to this numerator. Okay, so the original function is to the left, and we need this numerator to equal to this numerator for these functions to be equal. So notice that the numerator in the original function here has no x. That means we need to get rid of this term here. We need to get rid of this term, otherwise this numerator will not equal to the left side numerator. Therefore, this term must equal 0. This term must equal 1 for this numerator to equal this numerator. Okay, so our functions are a plus b equals 1. This must equal to 1 and this must equal to 0 for these two functions to equal each other. Okay, that's equation 1. And 2ab plus b equals 0, equation 2. So using equation 1, a equals 1 minus b. Sub that into equation 2. We'll be left with 2 times 1 minus b plus b equals 0. We'll simplify it even more. 2 minus 2b plus b equals 0. B will equal to negative 1, negative 2. Okay, negative b will equal to negative 2. B will equal to 2. That's your first value for the variable. We'll go back up here. Okay, go back here and solve for, using equation 2, solve for a, or using equation 1, much easier. So a equals 1 minus b, b is 2, 1 minus 2, a equals negative 1. These two values of b and a we'll sub them back up here, and we'll find the integral for each term by itself. So subbing in the values that we found, integral of -1 over 1 minus x plus the integral of 2 over 1 minus 2x. Now the rule for this type of function is the integral of dx over 1 plus alpha x will equal ln 1 plus alpha x over alpha. Okay, so we'll use this rule to solve each term separately. So the first term, this one here, will equal ln ln 1 minus x over -1 plus 2. The 2 will leave the integral because it's a constant, and the -1 will leave the integral because it's a constant, and that's the reason behind this -1 here and the 2 here. Okay, so it'll be 2 ln 1 minus 2x over -2, and that is your final answer. Till another video, see you then.